So good afternoon, everyone. Welcome to this edition of the NITheCS Colloquium. My name is Francesco Petruccione, and today we are very privileged to have Professor Hans Roosenschoon with us, who will speak about the interface between mathematics and music, so which is a topic that will interest many of us. Yeah. I'm very excited about this event because it's the first time that our colloquium goes hybrid. Yeah. So Professor Roosenschoon is in Stellenbosch in a venue where there are people physically in attendance. And I will ask now Professor Zurab Janelitzet, who introduced us to Professor Roosenschoon, to introduce our speaker. So Zurab, if you don't mind, you're welcome to introduce the speaker.
Thank you very much, Francesco. I think anyone who is even a bit knowledgeable about music in South Africa will need no introduction to Hans. I myself knew about him before I met him, and it was my great pleasure and honor to find out that he's a next door neighbor. And so I didn't lose the opportunity to talk to him, and it turned out that there is some interesting link with mathematics in his music, which he will tell us about, and we look very much forward to hearing about it.
Perfect.
Oh, thank you. Thank you, Zurab.
Thank you very much. Then over to you, Professor Roosenschoon.
Yeah, thank you very much. And hello to everyone where I am, and also to all the people that's linked with this presentation via Zoom. I think what I would like to do is to go straight to the music and play you something of that, because that would give you an idea of the sort of stuff that I write. So there we go. Okay, so that was the last movement of a work that's in 4 movements, and it was written for the Johannesburg International Mozart Festival, and it had to be a funny piece. So I based my material on quite a lot of Mozart themes, the main ones coming from his sonata in C major. And to me, the first theme and the second theme of this first movement of the sonata is very interesting. It's almost like a geometrical figure. And then we get these scales, okay, and that leads to the second theme, which goes, which is a mirror of the first theme, right? And then there's a passage in between that, which is what we call arpeggios, again, patterns. So for me, it was very interesting to find these 4 almost, you can call them circles and squares and things like that, very basic figures. What you are seeing in front of you now is a sketch that I made for this passage. What you've heard from the middle onwards was the piano plays scales up and down from the very right-hand side of the piano, the top of its range, and step by step it goes down right to the bottom. And it goes through different keys, which it's a technical thing, which I'm not going to explain, but with every step it goes down, it's in a different key. Although it's not in all the keys that we find in music, basically only 4 of them. And then the other players are making sounds based on the name Wolfgang Amadeus Mozart, sounds from his name and also extracts from other works and from the sonata itself. And basically what I've indicated here is to create a kind of, I very often look at music from the top down. I would put the page on the floor and I would look at it to have a kind of distance. And I try and see symmetries in it and so on. I mean, here it's very clearly that I thought about it in terms of 7-bar phrases. You can see the numbers with 4 being in the middle and so on. And I will come to another work where I also do this. So rhythm by numbers, what I will do today is I'll just throw a couple of things at you. And then hopefully in the question time, I can answer more. And I also believe there's a longer question after the session starting at 6. So, so what I do, I use numbers. And you can see here, I've sort of listed all the possibilities of 1 and 3 in different positions, right? Now, in this case, 1 would be, for instance, an 1/8 note long. I'm using here the American way of talking about durations. And the next note would be 3 of 3/8 notes, a dotted crotchet, we would say in English, and so on. And then I've listed a combination of 4 2 and 2 1s. If you add those numbers up, they will all come to 8 so that they can fit into a 4/4 bar. And the same applies to the other columns that you see there. In music notation, this is what it looks like. There we have top left, we have 3 1 1 3. Then we have next to it, we have 4 1 1 2. Then we have 2 1 1 4, and so on and so on. The nice thing about music, of course, is, I mean, here this is notated in what I would call a very straightjacket way. It's precisely within the bar and the meter of the bar. What I could do with a pattern like this, I can shift it for 1/8 up, and it will look totally different. If you listen to the rhythm, it will still sound the same. However, if I have another instrument playing the main beats, we will now have this offset between the main beats and the rhythm. Just going back to just the integers there, you know, I could take something from the left column and combine it with something in the right, in the next column, or the very last column, and so on. I can jump within this matrix from any place and, you know, so create different rhythms. What I found initially when I started to work with this was that, you know, to write the rhythms was fine, but then my brain said, now, what is the next rhythm? And what is the third rhythm? And so on. And then I would use figures like this in determining the answers that I'm asking. So I use another set of figures to actually select from this particular matrix, and so on. Okay. This is the second movement from the work that I played you something from. I'm not going to play the second movement because I think I need to also watch the time. But what you see in front of you are note names, G, B, D, F, G, A, and so on. And I've written numbers underneath. The whole idea here is I want to make, I see that top line, I see it as a chain or as a stream of notes. And I want to make continuous variations of it. So I would, the second variation, or the first variation rather, would be G, which is number 1, G again, which is number 2, B, that is number 3, A, that is number 4, B, that is number 5, etc. I would write that down, and I would then write that sequence in the top blocks. And I would, again, every sixth, you know, it's 1, 2, 3, 4, 5, 6, and again, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And by doing that, I eventually end up with something that just has equal note values, which is, you can call it a contour or a stream of sound. This is not what I derived from this example, but it's the procedure was the same. And then eventually I come to an instrument playing, and you will see there that in this case, it's the cello starting off. And so you have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, 1, 2, and so on. I use again numbers to indicate the length of notes and so on. Now, for me, the interesting thing here is that the three instruments, the violin, the viola, and the cello, they all play the same tune, but they do it in a specific way, or they play the same string. They don't start at the same time. As you can see, the cello started first, then at the end, the viola, and in the middle of that page, you can see that the violin on top also came in. Now, where that violin is coming in is not from the beginning of the stream, but where we are in the stream. Okay, and so it's almost like a canon technique in a way, although they are all playing the same at the same time. But because they are playing different rhythms, if some instrument is playing a note for 2 beats, it means one pitch is skipped as a result of that. The note that should follow doesn't sound. Do you follow this? Okay, so yeah, I just wanted to show you that. I'm not going to play it. So I'm going to move on to, we have done rhythm by numbers, and here I've worked out a sequence by using a sequence of notes, which I vary, and also using a sequence of lengths in a certain way that rotates and has an effect on what I call the stream of sound. Where this all started for me is, thinking of variation, and in its most simplest form, you can say 1, 2, 3, 4, or you can say 1, 2, 4, 3, right? Or you can say 1, 3, 2, 4, or you can say 1, 3, 4, 2, and so on. And we know that by you as the mathematicians know much better than I do, by just multiplying the 4 numbers, it comes to 24, and that tells you that there are 24 variations possible of the integers 1, 2, 3, and 4. And it's basically also that idea that I use. Okay. Chord by numbers. Now, I need to explain that in music, when we talk about the melody, we talk about the notes that follow onto one another and the intervals that we find in between, the spaces. And we use numbers basically to indicate that. We would talk about a major third or a minor third if that skip is either larger or smaller. Or as we have on the top here, we by putting 3 notes on top of one another, which is the other thing we do in music, is to create chords, harmonies. And in this very first example on the top, we have 2 and 2. So that could be a major second or a minor second. We'll see how that works. But what I did here, I wanted to get away from the sort of fixation that we have in tonal music with making chords only from thirds on top of one another, but using other intervals. And so I thought to myself, I asked myself, okay, I can have 2 and 2, or I can have 2 and 3, I can have 2 and 4, 2 and 5. I don't do 2 and 6 because then I go beyond the octave, which I don't want to do. And so that then gives me, these are all the possibilities that I got from the numbers that you saw in that table just before that. For 4 notes, then you have 3 intervals in between. So I started off with 2, 2, 2, 2, 2, 3, 2, 3, 2, and so on, getting all the numerical variations, and I hope I did get them all right. And so if you look at what kind of chords that produce, that's how that looks. What I didn't say just now is that the very first chord, obviously, you can take that up a step and another step up and another step up. So what you see there between the notes are what we call seconds. If I just go back to that, we see 2, 2, and 2. But I go up in the first octave with this, right? And there are many possibilities, as you can see. I try to notate all of them. And what makes some of them interesting is the larger spaces in between the notes. And so on the one hand, you have very close notes very close together. And on the other hand, you also have spaces, right? And I will talk about a piece just now where a very quick succession of these different structures. The Americans have a name for chords. They call them aggregates. So it's, putting notes on together in a single moment. And the spaces between the sounds are just as important as the sounds themselves, because that gives the character to the sound. And I haven't even spoken about the instruments that play it. Just to be more precise, I took one of the examples, and you will see now I've written 2 and 2 and 2 and 1. that simply says that from the note C to D is a major second, and from the note D to E is a major second. But the chord after that, the D to E is a major second, but from the E to the F, it is a second, but it's a minor second. And the best way to make this difference is to use one in that particular instance. And so the same principle holds in the rest of that top example. Below that, I'm just showing two ways of approaching, describing or labeling these sonorities or aggregates. In the bottom line, the first chord, C, D, E, F, G, you can number it or label it as 0, 1, 2, 3, 4, because it's the notes that lies next to one another. We talk here about the white notes of the piano. But what I put down underneath was to actually count the semitones between the notes. So we take C as 0 because it's the very first note that we start on. And then D becomes 2 because from C to D is 2 semitones. From C to E is 4 semitones. And then from C to F is 5 semitones, and from C to G is 7 semitones. The example just next to that, we see 0, 3, 4, 5, 6 at the top. But if you want to label that more precisely, it would have to read 0, 4, 7, 9, and 11. And in music, we indicate the 11 not with 2 1s, because then you can confuse it as being 2 different notes, where here it's supposed to be just 1 interval. All right. How are we going for time? Let's move on. In 1985, I wrote this work, Timbila, that was for a Chopin Xylophone Ensemble and Symphony Orchestra. The Chopin ensemble, the instruments, it's xylophones that they make themselves, handmade. They divide the octave into 7 equal distances, where in Western music we divide it into 12 equal distances. So these two tonal systems were not compatible with one another, and I had to find a way of getting around it. But here is what they found. Okay, that gives you an idea. I'm not going to read what's on the screen. I'm just going to, in my own words, quickly say that if you listen to a group of musicians, let's say vocalists with guitars and bass, guitar and drums, the layers that form, you can hear very clearly because of the different timbres that you are presented with. In the case of xylophone music like this, where the instruments are from one family, it's very difficult to actually hear the layers on top of one another. Unless you had an opportunity when you made a recording of a group of instruments, that you had a microphone on every instrument and you recorded it with multi-track, and then you can transcribe what every player is playing. But my contention is the player is playing here and there, they're moving around in their instrument, and someone else with the same instrument is not playing exactly the same, but somewhere in between. And so and that's what I then was going for and interested in, is to say, why don't we look at the music as slices rather than layers, but just a moment. What happens in this moment? And if they, with this music, the attack is very strong of every note. Let's see what that aggregate looks like. Okay, difficult thing to do. So basically, yeah, I wanted to speak about this. I mean, you can see this. I'm just sidetrack a little bit. This is an analysis I did of the middle section of the music that I just played you. But here I'm referring to the combination of orchestra and the xylophones. And you can see that what I tried to do at figure 1 at the bottom, if you look up, you see these black little beams, and they are in a certain position, whereas at 2, there are more of them and in a different position. If you look at 4, there are even more of them, you know. And so this gives you a very broad idea of the dark black represents certain aspects of the music, and the other colors represents different layers and things like that. But what I want to get down to is this particular piece, Menorah, which I composed in 2005. Again, I'm not going to read you everything here. It's based on the candelabra with its 7 candles. And so again, for me, the number 7 is very important here. And I will just show you that. So for this particular work, I created 7 times 7 chords, 49 in other words in total. And you can see in the top line, there are 5 notes every time. The line under that, there are only 3 notes every time. The line under that, there are 4 notes every time. And so this goes on. There's also a mixture of few notes and more notes and so on. The diamond notes that you see on top just indicates for me as the composer that these chords are hanging on the notes, like washing on a washing line, all right? The second line, you see the diamond note appears every time in the middle of the 3. And so that is the melody. And in that case, you know, for me, the chord is structured in such a way that the melody note is always in the middle. And then in the third line, you can see the diamond-shaped notes at the bottom. In other words, here, the notes are arranged on top of those melody notes, which is what we normally do in tonal music. Okay. So let me just play you. I end the piece with all 49 chords, and this is how it sounds. Now, this is where composition becomes very exciting, is the moment you start writing for instruments. So I have always found that my particular way of using numbers in order to create structures and things like that, that in itself helps me to a certain point. But then I have to take a step, a rather large step, and that is to select, how the instrument will play my idea and what that will sound like and what that communicates. So we get a sequence of 7 chords, which basically sounds like this. That's a machine playing, and you can hear it, not very expressive. And I don't use all 7 chords and all the variations, the 49 that I've created, all the time. So I create chains of 3 chords, and I would then use 2, 3, and 1. So I would use the 2nd chord in my row of chords, then the 3rd one, and then going back to the 1st one. Or I would start with the 4th one, go back to the 2nd one, up to the 3rd one, back to the 1st one. My whole idea is here that the 1 is a kind of resting point. In other words, it's a goal. Like we have in tonal music, we have goals. But this is just a different way of creating that feeling of goal. And so I have groups of 3, 4, 5, and 6, 7. And obviously, I was just playing a game. It all adds up to 34, which gives me my 7 again. All right. Bit of numerology, perhaps, and not mathematics. Anyway, so here are more examples of the 7 note chords, just to hear how different it does sound. Right, it's not very human because it's very machine-like. In this slide, you can just see how I layered chord progressions with rhythms. This is a sketch from my work. I still had to, at this point, I had to decide, well, which instruments would play the top line, which instruments would play the second line. I think the 3rd line is just a sort of guide track. And then there's in the bass, also lower bass, we also have a figure. And taking you just back to this choppy music I played you and the complexity of that. This is how I was hoping that I would achieve that sort of complexity. Is instead of having single notes being layered, I have aggregates, I have groups of notes that happen, they come very fast after one another. Not always. I'll play you an example. This is just to let you hear. Now we have rhythm with it also. No, sorry. And this is how it sounds in the orchestra. And then here's an example of the chord progressions are in 2 layers. That's a plucked sound with a bow sound answering. Anyway, and then lastly, something that's a bit faster. Good. Then I worked with somebody because I was getting more and more interested in time in music and see if I could work with that very separately from anything else. I have to admit that until now, the experiment didn't really satisfy me, because to listen to rhythms all by itself, just clicks, doesn't say anything. You need pitch, you need warmth of sound and all that, that goes with it. Nevertheless, we developed this program, a computer program, that was statistical. So you could say, I want X% of 16th notes, I want so much percent of 8th notes, and so on. And that gives you an idea. In the top line, the percentage is 70 for 16th notes, 15 for 8th notes, 10 for dotted 8th notes, and 5% for quarter notes. And then different percentages in the second line, different in the third line, and so on. But then I tried this out with a pop song. I created a rhythm track. You can see there that I split up the drum set just so that I can capture the sounds much better. What you are about to hear is, using sampled sounds, so it sounds very electronic. That just gives you an idea. So let me play you that sound example. All right, so I realize, of course, that my talk did not touch upon the most characteristic work to date, or examples of systems based on their most prominent features, such as mathematical models, knowledge-based systems, grammars, evolutionary method systems that learn, and hybrid systems. It appears that research in the field of computer science-based composition has literally evolved and expanded over the last 30 years and developed into a variety of interrelated approaches that is generically referred to nowadays as evolutionary computer music. Likewise, there are many researchers who have developed computer programs that can handle increasingly complex problem-solving procedures that relate to creativity in music. And without knowledge of at least one computer programming language, creative artists are at a loss. Neither can they begin to understand the fundamentals of chaos theory, Markov chains, and the combination of various statistical models, etc., or neural networks for that matter. So from my presentation, I think you could see that I work very intuitively, yet it's a very important facet of my music, and it helps me a lot. This abstract side helps me. And thinking aloud. I think with mathematicians, the numbers in itself, and please help me if I'm wrong, the numbers in themselves, if you see them, it doesn't mean much. It's when they are used within formulas, equations, and so on, and the type of answers that you get, that's when you get excited. Similarly, in my case, the numbers by themselves don't mean much, but if they are stepping stones for me to write a kind of music that I can identify with, which I can think, this is really the sort of music that I would like to write. So then finally, I just want to play you this. Thank you for listening.
Yeah, thank you very much, Professor Roosenschoon. It was just fantastic, and it was really insightful to see how you shared your way of operating when you compose new music. It was really very interesting. Thank you so much. I would like now to ask Zurab to please guide us through the Q&A session, Zurab, if you don't mind. And again, an invitation to the participants to raise their hands so that we can give them the right to speak if they are joining us virtually. And if they are joining in person, Zurab, it's up to you. Yeah.
Okay, so I don't think we have anything in the Q&A session that needs answering.
There is a raised hand, and I just made Coral a panelist. So Coral, please, you can unmute yourself and ask your question.
Thanks, Francesco. Thank you very much. Enjoyed the lecture. I've had quite a bit of an interest in computational creativity, and in particular, computer-generated music for quite a while now. So I would have actually really enjoyed some of the things that were left out of this lecture. My big question to you, though, was in the various models that you use to store your both the chords and the rhythms, do you have any known methods of keeping track of symmetries in those, either inversion of chords or repeated patterns that are made at a slower or faster point of view, that kind of stuff? Thanks.
Okay, so if I understand you correctly, you want to know how I keep track of everything and the patterns within it.
The symmetries within
Symmetries.
Specifically symmetries where you, for example, have a pattern that's repeating at a faster, slower pace, or a chord inversion that is repeating at various times in the music. I was just wondering if you have ever considered those, and if you do, how do you model them?
Yeah. Look, as I said at some point, I think if I'm glad that you made the remark about computer. I think if I at this stage start with using a computer in what I do, that would actually be great. I think it can be of a great help to one, and it could also assist greatly into identifying the sort of symmetries that you are referring to, because at the moment, everything I do is by hand, and I keep this in notebooks and so on. The other thing that I do is that for every piece I generate a new system. I don't like repeating myself. So that then brings about that I'm not really that focused on finding or creating certain chord structures that have either certain similarities between them and not. I hope I've answered your question there.
No, that does. I've had quite an interest in the artificial intelligence algorithms that sort of learn music via probability theory. and then reuse it to generate new stuff. There's a wonderful book called Music and Probability by David Temperley. That's a wonderful read. But thank you for answering the question, much appreciated.
Maybe I should have a look at that book.
David Temperley, it's called Music and Probability.
Okay, thank you.
Sweet.
Thank you, Coral. Zurab, I'm not sure if you have questions from your audience in Stellenbosch.
Yes, we do.
Yeah, please.
We do have some questions here. I just want to see if these questions can be heard. So I'm going to do a little experiment, Francesco, if I may. I'm going to take the microphone to the person who asks the question, but if you can't hear it, then I'll ask the person to come to the front to ask the question here.
Perfect.
Can you hear? You can also say hi in the camera.
I'm not sure whether you can hear me now.
Yes, yes, we can.
Okay. I just wanted to ask that, was it the xylophones, right?
Yes.
So you talk about some sort of focus on the sort of in the moment, the structure of all the different layers from moment to moment, as opposed to sort of melody accompaniment. So I just want to ask if you draw a distinction between that sort of music and, for example, polyphonic music like Bach fugues or something, right? Is there sort of a distinction that you would draw between those two types of music? And then I also just want to ask, where are those people, the marimbas?
Mozambique.
Mozambique. Okay.
Yes. Okay. Yes, if we listen to Bach's music, it's often performed on, different instruments. Or if it's piano, you think of 4-part fugues and so on. It gets very complex because of the 4 parts and the fact that you can't play many notes on the piano. But still, it's easy to follow. In the case of the xylophone group that I worked with, they normally play in groups of, 25 to 30. And then also they play on 3 different sizes of instruments. And I just found, well, in my score to the work, I just have a symbol indicating what they play, because the whole idea of the piece was that they play something that they know, that comes from their repertoire. And I listened to a recording of that and found a way of mixing the orchestra with it. So you can say that the Chopi instruments, because once they get playing, it's like a wall of sound. It's very powerful. There's very high-pitched sounds embedded in that, which makes it a bit like the sound like distortion. And it has a very strange effect on especially bass notes in the orchestra. You just don't hear it. It's an acoustical effect. So, but for me, I think of music as 3-dimensional. So we have layers from high, middle, low, or from low, middle, high. So we have a vertical dimension. Then we have time, which is extremely important in music, because without that, we would not hear a sound. I mean, if you play something at a very, if you play something played by a symphony orchestra, and you play that for a split second to a friend, they won't be able to tell you, oh, that was a symphony orchestra. It would just sound like a click sound. So time is very important in music. But then there's also diagonally, or from front to back, there's an importance to me, because if sounds are played short as opposed to long, they present themselves, the shorter sounds present themselves more to the fore than the sustained sounds. Obviously with the different timbres of instruments and so on, you can play around with this sort of dimension, with this three-dimensional space. And then you also can add to that, of course, the performance in the space where the music is taking place, which is a different three-dimensional experience from what I'm talking about, which is, I think, more abstract.
Thank you.
So meanwhile, we have a question in the Q&A session. Very interesting talk, thank you. I really enjoy the structure and how you can play around with mathematics, fascinating. Would you say that a computer programmed piece of music would sound good? I actually want to know if you still need to listen to your music when you use these patterns and percentages to hear if it sounds good, or can you just create a piece by choosing the numbers ahead in a specific calculated way?
Yeah, to be honest with you, thank you for this question. It speaks about my approach, really, and that is, I said this earlier in my presentation, that I reach a point that I cannot trust just the numbers. I have to think further about the instruments that I'm writing for, how they play, exactly how they play. In the case of a violin, is it an up bow? Is it a down bow? What is the dynamic? On what string is the instrument playing? And so on and so on. I have found in the study that I did make of some composers working with, for instance, taking prime numbers and converting prime numbers into pitches. I've never found that sort of result, which is very minimalist, and I'm a fan of minimalist music. But somehow that minimalism, it's as if the translation from the integers to sounds, it's too direct, and there's no further critical engagement with what the piece actually sounds like. Similarly, I have come across people that use the DNA structures and the numerical representation of that, which you can also convert to pitches. It's this conversion which is the problem. You cannot just it's not just a direct translation. It gets lost in translation, to refer to that wonderful movie. It does get lost in translation. So you need to really work at it. Lastly, I could say, and on a positive side, I've come across work. There's an American composer, David Cope, that has used computer programs to imitate musical styles, such as nocturnes by Chopin. And he got a pianist to play those compositions and also mixing it with Chopin's own music. And apparently, for most of the people in the hall, it was very difficult to distinguish stylistically between the one and the other. Yes, of course, people would recognize this nocturne or that nocturne because they've heard it before, but then all of a sudden they hear a nocturne and it sounds exactly like Chopin, but I don't know it. So I think there is something that one can do there. And what I'm also very much interested in, there's a center in Paris, IRCAM. They do acoustic research and music research, and they have developed programs where you can record a sound and then give it to the computer to analyze, and the computer will tell you what instrumental combinations, including percussion and so on, will give you that sound that you've heard somewhere. How you can create that with ordinary instruments, and you have various choices.
There is one more question. If is it fine, Francesco, from the audience here?
Of course, please, please, of course. It's very, very, very fine. It's
Hello. So,
Hi.
hi, Francesco. So you showed in the beginning you permute with the numbers, you kind of create all the permutations, which is kind of like the mechanical ways, but it sounds very mechanical. And then you reach a point where you add that human element to make it maybe in your head sound nicer for you. So I was wondering at that critical point, how much of Western music theory do you use to change the permutations to sound nicer? So like use more fifths or those kind of intervals? Or have you found that looking at it this way allows you to find different ways that still sounds nice, but isn't as Western or as reliant on that kind of framework?
Okay. Yeah. Yes, of course, my Western training is very important. The fact that I studied orchestration and also for many years taught orchestration at this university and composition and so on. And the fact that I listened to a lot of contemporary music, often without scores, so I couldn't see what the music looked like. I could only hear what it sounded like. And so I had to imagine what instruments it is that I'm hearing together. And obviously that all adds to one's knowledge. You know, the moment you take a structure as I showed, you can, obviously, any structure that is just a very basic thing. I mean, if I think of music theory, this is how I would try and answer you. If you, in theory, we would say, okay, a C major chord, how do you write that? That's C, E, and G, right? 3 notes on top of one another. And that represents an entity, a certain sound, where there's a major third in it, there's a minor third in it, and there's a perfect fifth in it. But then if you look at how a composer scores a C major chord in an orchestra, or how Brahms, you know, writes it with arpeggios on the piano, you then discover, well, you know, that symbol is so abstract, it actually tells you nothing, because it's what the composer does with that concept, how the instrument is utilized. You know, how high is it going? I mean, you know, C major in the middle of the piano or at the top of the piano or at the bottom of the piano sounds like 3 different C major chords. So theoretically, it's the same thing, but acoustically, it's different. So, yes, of course, I have to amend something that starts off very abstractly. I have to make amendments to satisfy my ear. And that means I would start doubling certain notes. I would add an octave or even 2 octaves above it. Why? To give it a particular color. Now, I think this is an area, this where you expand from something abstract to something real, something sounding. I think that's perhaps where in the sciences, there's still a lot of work to be done, you know, how one can suss that out and with artificial intelligence, create possibilities to get to a good result in, you know, just so much faster.
Thank you.
All right, so thank you so much, Hans. It seems there are no further questions. Francesco, we can try to join Kumo Space from here.
Yeah, no, that's what I asked in the chat. Today it's
Let's see how it works.
few first events for all of us. Yeah, no, that's perfect. Right. Then Professor Roosenschoon, thank you so much for your really exciting talk. I think that everybody was fascinated by the connections that you explained to us. And I would just like to invite the participants to interact with you in our virtual social setting called Kumo Space. And we'll try. We've never done this in a hybrid format before, so I don't know exactly how it will work, but we will try. And I hope to see most of you there as well just now. So thank you very much again for the nice talk. Thank you very much to all the participants. And thank you, Zura, for organizing this first hybrid event. And I'm sure this will be a little bit the standard going forward. Yep. So thank you very much, everyone. Have a good evening. And I hope to see you again just now in Kumo Space. Thank you very much.